Hello viewers, you are welcome once again. We are still under logic, Christ Almighty, God's Algebra. We are going to treat Law of Idempotent. In Law of Idempotent, we have Law of Idempotent by Conjunctive Statement and Law of Idempotent by Disjunctive Statement. But we are going to start with Law of Idempotent by Conjunctive Statement. Let us start. Law of Idempotent. P is equal to P and P. This is an example of Law of Idempotent. P is equal to P and P. If you look at this very equation, you will find out that whenever the P at the right side of the equation, sorry, P at the left hand side of the equation is true, also the P and the P at the left hand side of the equation must also be true. In the same vein, whenever P and the P at the right hand side of the equation is false, also P at the left hand side of the equation must also be false. We say that the equation is logical equivalent. That means it is law because the two sides of the equation, they are equal. We call it logical equivalent. Also, you observe that P and these two P, they are being combined by and connective. That's why we say that it is conjunctive statement. That's why we say it is law of idempotent by conjunctive statement. The two conjuncts, they are being combined by the and connective. Let us prove this law called idempotent, called law of idempotent. Proof. Suppose P is equal to P and P. We assume that the statement is true and is our hypothesis to prove law of idempotent. And we say that in this statement, P equal to P and P, whenever P at the left hand side of the equation is true, also the P at the right, P and P at the right hand side of the equation also must be true. In the same vein, whenever P and P at the right hand side of the equation is false, also the P at the left hand side of the equation must also be false. We say that it is logical equivalent. So since the equation is logical equivalent and it is law, we are going to transform it to biconditional statement. And it must also preserve truth. If and only if P and P. We have seen that we have now transformed the equation to biconditional statement. And you can find out that whenever this P is truth, also P and P must also be truth. What I mean is P, I mean the left equivalent. Whenever it is true, also P and P, which is the right equivalent, must also be true. In the same vein, whenever P and P, the right equivalent is false, also P, the left equivalent, must also be false. You say that the statement is tautology because if we evaluate the statement, there's no possibility of getting falsity, always truth. That's why I say that it is tautology because you always get truth whenever I want to validate the statement. You say that is tautology. Being justified by logical equivalence. Being justified by logical equivalence. So if and only if, since this statement is tautology, P, if and only if P and the P is tautology, we are going to transform it to conditional statement and we shall still preserve tautology. If and only if P implies P and the P. We found out that whenever the P, this P that is antecedent is true, also P and the P, which is the consequent, must also be true. And if that is the case, we say that in the evaluation of this statement, when you want to evaluate this statement, there's no possibility of getting falsity, always truth. We say that statement is tautology. Since there is no possibility of getting falsity in this statement, whenever I want to evaluate it, we say that the statement is what? Is tautology. Is tautology being justified by logical implication? Being justified by logical implication. Now, since this statement P implies P and P is tautology, we then deduce that P is logical implication of P and the P. That means it's a proper implication of P and P. That means it is certain that P exists because there is no possibility of getting falsity in the version of this statement. P implies P and the P, always truth. We then deduce that it is certain that P exists. And if it's certain that P exists, we say that P is logical implication of P and the P. That is the consequence. Say if and only if P is logical implication of P and the P. Since this P, the assistant is logical implication of P and the P. If this is true, this is true, also this must also be true. So if and only if P is equal to P. That means the logical implication is equal to itself. And it is true that the logical implication is equal to itself because it's logical equivalent. In the sense that whenever the later side of P is true, also the later side of P must also be true. In the same vein, whenever the right side of the P is false, also the left side of P also must also be false. So in the equation, say that it's logical equivalent and it is true that P is equal to P, being justified by identity. Being justified by identity. He said if and only if P is equal to P and bracket not P or P. You see that we add P, not P or P to this P. Why we add it is because it is conjunctive statement of law of idempotent. That's why we make it to be and. Then tautology, which is written as P. So whenever, because not P or P is tautology, and whenever tautology is and with any term, is written as that term. So P and bracket not P or P is equal to P. So being justified by law of identity. By law of identity. By law of identity. If and only if P is equal to not P or P upon not P. We see that P or P, not P is now implies to not P or P. That means this and this conjunctive statement has now been transformed to conditional statement. It becomes not P implies not P or P. Being justified by Christ Almighty God's grace. It is by Christ Almighty God's grace that we transform P and bracket not P or P to not P implies not P or P. And the fact that this statement is no more equal. That means P equal to not P or P upon not P is no more logical equivalent. The right hand side of the equation now is now greater than the left hand side of the equation. We say that it is intensification of P. That means the left hand side of the equation. Because not P or P upon not P is tautology. That means it's not greater than P because P is a substate of tautology. Is intensification of P then being justified by Christ the Almighty God's grace. That to say that bracket P and bracket not P or P is equal to not P implies bracket not P or P, not P or P is intensification of P and bracket not P or P. If and only if P is equal to, we are going to distribute not P, that is the implication, not P, the implication of not P or P. We are going to distribute it between not P or P. That means we are going to have not P upon not P. Or let's continue to this side. If and only if P is equal to not P upon not P or P upon not P, you will find out that this is also grace because it's tautology. P, not P upon not P, that means not P implies not P is tautology. And tautology, all with any term is written as is equal to tautology. So the right hand side of the equation is tautology, which is greater than the left hand side of the equation, which is P. We say is intensification is intensification of P being transferred by distribution of implication. That to say that not P upon not P or P upon not P is equal to not P implies not P or P, not P or P. So if and only if P is equal to this not P upon not P or not P upon not P or P upon not P, they are inconditional statements. We are going to transform them to conjunctive statements because this implication is being this not P is being generated from the conjunctive statement. That means P and bracket not P or P. Since it is being generated from the conjunctive statement, anytime I want to revise it, it will going to be in conjunctive statement. So if you want to revise this not P, it's going to be in conjunctive statement. That is to say, we have P and not P, or P and the P. You see that this side now, P, this equation now, they are now logical equivalent because the left hand of the equation is equal to the right hand of the equation. So, being justified by Christ the Almighty God's grace. That to say that bracket P and not P, or the bracket, or bracket P and the P is equal to not P upon not P, or P upon not P, is intensification of P and not P. Or let's continue to this the other side. That to say, since it's by Christ Almighty God's grace, that to say that bracket P and not P, or bracket P and P is equal to bracket P bracket not P implies not P, or bracket not P implies P is intensification of bracket P and not P, or bracket P and the P. That means this not P upon not P, or P upon not P, is equal to P and not P, all the brackets, or P and P by grace. That's why I say it is intensification. So it's by grace. If and only if P is equal to, now you see that this P and not P is equal to F. I mean, it's equal to falsity. That to say that this P and not P is F, being justified by law of complement. So by law of complement, P and not P is equal to 4CT. That means we have P equal to F, or bracket P and the P, and it's still law because the two sides, they are logical equivalent. So being justified by law of complement. That to say that P and not P is equal to F. And whenever falsity is all with any term is certain as that term. That means is if and only if P is equal to P and the P. So by law of identity, when contradiction is all with any term setting as that term. So it just fine by law of identity. We then conclude, we have now proved that P is equal to P and P. That is our thesis. We have now proved it that P is equal to P and P. So we conclude, we say, thus P is equal to P and P. Since the statement is law, that means it is logical equivalent. We are going to prove the converse so that we can establish by the principle of extensionality, we then establish that P is equal to P and P is law of idempotent. So conversely, P and P is equal to P. You have seen that this P and P at the right side of this equation has now become P and P at the left side of this equation. Then P at the left side of this equation has now become P at the right side of this equation. We say that it is converse. So you want to prove it that P and P is equal to P. So suppose P and P is equal to P. That means we assume that the statement is truth, and it's our hypothesis to prove that it is truth. So it says suppose that P and P is equal to P. Since whenever the left side of the equation is true, also the right side of the equation must also be true. In the same vein, whenever the left side of the right side of the equation is false, also the left side of the equation must also be false. You say that it is logical equivalent. Since it is logical equivalent, we can transform it to biconditional statement, and it will still preserve logical equivalent. It will still be logical equivalent and it is truth. So if and only if P and P, if and only if P. You see that in this statement called biconditional statement, whenever P and P, that is the left equivalent, is truth, also P, that is the right equivalent, must also be truth. In the same vein, whenever P, that is the right equivalent, is false, Also P and P, that is the relative equivalent, must also be false. So in the version of this statement, we say that the statement is tautology because there's no case we're going to obtain falsity when we relate this statement. Always truth. We say that statement is tautology. Is tautology being justified by logical equivalent? By logical equivalent. So if and only if, see, this statement is tautology, that means P and P, if and only if P is tautology, we also are going to transform it to conditional statement and it will still preserve tautology. That's P and P implies P. And you see that whenever the antecedent is truth, also the consequence must also be truth. So if you want to this statement, when you want to violate it, there's no possibility of getting positive, always truth. We say that the statement is tautology. Is tautology. Being justified by being justified by logical implication. Now, since the statement is tautology, that means P and P, as antecedent implies P is tautology. It means that it is P and P is proper implication of P. That means it is certain that it exists. It's certain that P and P exist. And if it's certain that it exists, we say that P and P is logical implication of P. If and only if P and P is logical implication of P. P and P is logical implication of P. Since this is truth, also this must also be truth. So if and only if P and P is equal to P and P. That means the logical implication is logical equivalent. That means logical implication is equal to itself. And it is true that the logical implication is logical equivalent was it is equal to the itself. That's why I say that P and P is equal to P and P. Being justified by identity, the sameness. By identity. Say if and only if P and P is equal to P and P. And bracket not P or P. we have now added tautology to this statement, and the same thing as the P and the P. Because whenever tautology is handled with any term, setting as that term, that means P and the P and bracket not P or P, which is tautology T, is equal to P and the P. So it's the law, which is justified by law of identity. Law of identity. Let's go this side. If and only if P and the P is equal to P and P and P and P and P upon P. Now, this P, not P or P, has now been transformed to conditional statement. That means it's equivalent to conditional statement. That means by first education law. So it is not P or P is equal to P implies P. So you see that it's still equal to this side. That means P and the P is equal to the right hand side of the equation. That means P and the P on the bracket and P implies P. And P implies tautology, which and the term is same as that term. So it's still law. So being justified by first educase law. First educase law. Being justified by first educase law. Say if and only if P and P is equal to, we are going to distribute this implication P to P and the P. That means we have P upon P and P upon P and the P being justified by distribution of implication. That to say that this is equal to this. If and only if P and the P is equal to, we are going to transform all these statements, these conditional statements, to disjunctive statement, because this implication P is being generated from the disjunctive statements. So whenever you want to transform from to another form, I mean from conditional statement to another form, it will going to be in disjunctive statement because it's being generated by disjunctive statement. So we have P or not P and P or not P and the P and the P. So by also by first Ejike's law. By first Ejike's law. So if and only if P and P is equal to, you see that P or not P is equal to T by law of complement is equal to T. That means we have T and D. T is setting here P and P or not P is equal to T. And P being justified by law of complement. If and only if P and the P is equal to, then whenever tautology is and with any term set at that time, like tautology and with tautology is tautology. And we have T and the P being justified by law of identity. If I go to this side, say P, if and only if P and the P is equal to P, because when tautology is and with any time set at that time, that means T and T and the P is equal to P. That means P and the P is equal to P. That means T and the P equal to P. Being justified by the same law of identity. By law of identity. You have now proved the converse. You have now proved the converse that P and P is equal to P. So converse also holds. Since converse holds, we then establish that P equal to P and the P is law of idempotent by conjunctive statement. So therefore P is equal to P and D. Sorry, since you have not proved the converse, we say thus P and P is equal to P. Having proved the converse by law of essentiality, by principle of essentiality, we then establish that P is equal to P and D P. We say therefore P is equal to P and D P. That is, it is law of idempotent. So we have now proved that law of idempotent exists in conjunctive statement. So at this juncture, we will draw our curtain. Thank you, viewers.